So many thanks to Sven and Didier and Alexander for inviting me to speak at this very interesting conference. I'm going to take an outside perspective for the next 30 or 40 minutes. We've been hearing about the inside, the activist movement, the research into longevity. I am now going to look at the critics of longevity, the people who feel that we're actually wasting our times here. People feel that we're only going to have very modest success and that we're going to be disappointed. The people who sometimes feel that we're deluded or even that we're dangerous. So I'm going to be looking at what some of these critics say. And I think we can learn some things from them. I'm also going to be giving an external perspective in another sense. I am not a geneticist. You will not find in my slides biochemical pathways. You will not see long strings of methyl groups and benzene rings and chemical formulas. I don't own a colony of C. elegans worms or mice or rats. I don't have Drosophilus fruit fly. The nearest I've got is a small colony of cacti that I try to keep alive by remembering to water occasionally, but I don't try and knock out the genes. But I will bring my perspective, first of all my training in the History and Philosophy of Science department, where I spent 4 years doing doctoral research. I think there is a lot of insight that can be brought by taking a historical and philosophical science viewpoint on this. And I'll also draw on my expertise from my business background, where I spent 25 years in a different business, that is the mobile computing, mobile phone business. And actually, if you go back 25 years, if you asked people, if you asked yourselves or maybe your parents, do you think you'd like to carry around with you a device that people could use to contact you any time of the day or the night? Most people would say, no, thank you, I don't want to be disturbed. And there's been a big change in public perception about that.
It's a little bit too high.
It's too high, right.
Yeah, you're doing it too well.
Doing this too well. Right, there's a big perception of initially people in the outside, people in the street, they mixed views about longevity, but I foresee in the next 25 years there will be a big change in perspective too, and for reasons why. So let's look at some of these critics. This is happy smiling face here, why I hope to die at 75. This was in the Atlantic a couple of weeks ago, and if you can't read the small print, he said, this is an argument that society and families, and you, that's you'll all be better off if nature takes its course swiftly and promptly. And this guy is no fool. This guy, Ezekiel Emanuel, is director of the Chemical Bioethics Department at the US National Institutes of Health. He's head of the Department of the Medical Ethics and Health Policy at the University of Pennsylvania. He also had a prominent role in Obama's Obamacare campaign. So we will come back and look at what prompted him to give these statements, and if there's time we'll look at some other critics as well. Now let's take a look at these couple of 75-year-olds. So apologise for a bit of photoshopping that's going on in the next slide or so, but here's a happy pair of 75-year-olds enjoying a quiet time in the beach. Before, if they followed Dr. Emanuel's advice, they'd stop taking flu vaccinations and blood tests, and they'd quietly degrade over the next few years. Well, in our vision, the people who believe in healthy longevity, one vision is that if we look ahead to 2050, they'll be like this perhaps. Aging will have been slowed and perhaps stopped, and that is one thing which Dr. Emanuel is not believing in. And there's a more radical proposal, of course, which is that by 2050 the muscles will be retoned and lots more vigor, youth will be brought. So that is the vision which these critics think is dangerous and misleading and naive. And I'm going to look at it from a historical point of view. I want to compare this vision of rejuvenation, something that has intrigued and excited people from all parts of the world throughout history. I want to compare that with another vision, the vision that one day people could soar into the clouds and take control of their own destiny as to where they flew. And this has had a long history too. There have been stories since the beginning of history about the possibilities of people flying and the dangers of people flying. Hence the story of the myth of Daedalus and the Icarus and many others. Let's look at this comparison. people say, well, human rejuvenation is bound to be impossible because, well, it's against the law of entropy, you know, the second law of thermodynamics. Things inevitably decay. Just as they say flight has got to be impossible because what goes up has got to come down quite quickly, there's the law of gravity. And there's the conservative religious opposition to both views. The view that if God wanted man to fly, he would have given us wings, a statement that was quite common more than a century ago. And of course, the conservative religious view of rejuvenation is coloured by religious texts, such as the 3rd chapter of the book of Genesis, where God punishes man and says, "For dust you are, and to dust you shall return." But the critics are more than just naive people. The critics are more than just conservative religious spokespeople. There have been many eminent critics of both of these grand projects. And the eminent critics, in many ways, have picked up on some of the naive, flawed, and snake oil theories of flight. And similarly, the critics of rejuvenation have picked up and criticised and worried about many of the naive, flawed, and snake oil theories of rejuvenation that have been around. And in both cases, there have been people who have been deeply misled. There were Indian fakers who promised they could levitate and climb up ropes. There have been people who said if you transplant monkey testicles into your own scrotum, then you will live much longer. And lots of other wild ideas which people ruined their health with. Even the first person in history who was recorded as seeking advice for longevity, the Emperor of China, what potions did he take? Well, he took potions with lead and arsenic and mercury, and as a result he died at the age of 49, and no longevity for him. Let's look more deeply at some of the critics of flight. The actual first powered flight by humans in which they could actually get off the ground and steer where they were going was in 1903. This is a critic from 1901. He is a formidable person. He was the chief engineer of the US Navy, Rear Admiral George Melville, who had done a great deal of work in his career. He had brought a great deal of new order and discipline into the US Navy. He had solved some of the problems of bureaucracy there, and he's lamented there has been no field where so much inventive seed has been sown with so little return as in the attempts of man to fly successfully through the air. And he published a 12-page document in one of the leading journals of the day, in which he went again and again into limitations. He said, look, if you want to get up in the air, you've got to be small. You know, insects can do it and birds can do it, but as soon as there's something big enough to hold a man, it's impossible. And then he turned on the scorn. He said, who are the people who are promising they can do this? They are purveyors of false hopes, the mechanical moonshine, and downright charlatanism. And you may hear echoes of this in critics of longevity today. And he was worried about the people who would be caught up in excitement, who would invest their life savings in these new companies that would promise flight, and there would be appalling catastrophe with a loss of savings and with a loss of life. That was 1901. Step forward to 1902, and we come to Lord Kelvin. And it's one of the brightest people of his generation. He is the person after whom the absolute zero temperature scale is named. He formulated the first and second laws of thermodynamics. He was professor of physics, full-blown professor from the age of 22. And he had a different set of worries. He didn't worry so much about getting up in the air. He knew that was possible, but he worried about navigation. And he really thought, you can't take control of your own destiny when you're up there. And when he went to America, a reporter caught a hold of him, and the transcript of the discussion is recorded in the New York Advocate from New Jersey, 1902. The interviewer said, do you think it'll be possible for an airship, this is not an airplane, an airship to be guided across the Atlantic Ocean as some far-seeing visionaries had promised? And he said, no way. He said, not possible at all. No motive power can drive a balloon through the air. And what about these newfangled airplanes that people are talking about? No balloon and no airplane will ever be practically successful. But the interviewer didn't stop there. The interviewer knew that there was successful experiments with gliding, for example, in Germany. And he said, well, what about these gliders, Lindenthal, I think the newspaper's got the name a bit wrong there. He used a gliding machine. He started from an elevation and he rode the slope of the air. And Kelvin's response is, well, what happened to that guy? He threw away his life. He was killed during his experiments, which is true. In 1896, his glider stalled, crashed, and 2 days later he died in the hospital. Though he did say his last dying words to his brother were, in German, "Sacrifices must be made." But that wasn't the view of Kelvin. Kelvin said that he and others who had similarly died were giving away their lives without any possibility and success in what they were undertaking to do. That was 1902. Let's step forward to 1903. There is another formidable person, Simon Newcomb, the founding president of the American Astronomical Society. He did lots of experiments, lots of observations on astronomical data, which are still well regarded today. He wrote lots of books on mathematics. He wrote even a book on political economics that many years later John Maynard Keynes said was very interesting and plausible. He was fed up of all the money that was being diverted into harebrained schemes, as he saw them, for flight. And he said, look, we've got to realize, just as mathematicians have figured out you can't square the circle, you can't duplicate the cube, we're going to have to figure out in the same way that aerial flight is one of the great class of problems which man can never solve. And his concern was different. It wasn't getting up in the air, it wasn't navigating, it was how do you stop? You know, once you're flying, what do you do? You know, if you start and stop, you're going to crash out of the air. You can tilt the airplane, and he was reflecting on the way that the glider people had come into trouble. How is he ever going to stop? And he exceeded himself further. He said, nobody's ever worked this out, nobody's figured out how to do it. And he wasn't foolish. He was actually basing his observations on what was a very public attempt to flight. There was a person called Samuel Piedmont Langley, who was the secretary of the Smithsonian Museum. He tried twice publicly in 1903 to get a steam-powered, engine-driven airplane off this contraption in the Potomac River near Washington State. And what was the result? It crashed into the water both times, as the newspaper journalist said at the time, like a handful of mortar. And the newspapers were merciless, and they called this Langley's folly. And they were particularly angry because of all the money. How do I switch off this wireless thing and stop it interfering so much? Is there any hardware button that I can stop? Maybe not. Anyway, so what the people concerned about is that they'd already spent $70,000 in funding from DARPA, or the equivalent of DARPA in the day, and in modern money, it's something like $2 million. Sven, do you know this laptop well enough to stop it informing us?
Can I close
Yes,
it?
you can close this. So these people, as I said, they were no fools. They saw plenty of evidence that this whole enterprise was taking public money and it was just leading nowhere. You've done something magic now.
I just disconnected from the internet, and I hope, because it's in a connection, that it always finds you guys. I hope.
Right, let's get back to let's go back into the past before we jump forward into the present day. So that was three formidable critics. The fourth and most interesting critic stated even more starkly. He said, in 1901, not within 1,000 years will man ever fly. Do you know if you know who said this? Somebody who was really depressed about the whole prospects of this great flight project. It was Wilbur Wright. Wilbur Wright, the one who 2 years later did get off the ground. And he was depressed because they'd been doing experiments all summer with gliders. They had new theories about how to get more lift, and their experiments had failed. That glider had come down several times. Both brothers had suffered very awkward bumps. They'd also tried to put their bicycling expertise. They were bicycle engineers. They knew about balance. They'd figure out new schemes to steer the thing, and it all gone wrong. And they confessed to his brother on his way home from the experiments, I don't think this will ever work. 2 years later, of course, after lots and lots and lots of hard engineering work in the meantime, there was a different picture, which is the first actual flight off the ground. And what's really interesting is that nothing much happened after this for the next 4.5 years. And why? Because the Wright brothers, they were trying to secure their patents. They wanted to make sure that their own inventions would be protected. They didn't do much to publicize their work, and they also practiced flying a bit more. News about this got round, it came to Europe, and people in Europe said, you know, that's not really flying. It's just bouncing off the ground. It's a bit like, you know, there used to be these pictures of transcendental meditation yogis who claimed they could fly, and you could see them, and you look at them, and are they actually levitating, or are they just bouncing up and down? So there's a lot of criticism. But then, a few years later, after they'd got their patents, they split up. One of them did flying trips in America, and then in France, and they were flying way off the ground. They were flying in figures of 8, and everybody could see, my God, something remarkable is happening here. It's not just smoke and mirrors. What happened next? Well, one of the people in the crowd that day in 1908 in France was somebody called Louis Blériot. He'd been doing his own tentative experiments. He figured out what he'd been doing wrong, and within a year, he had won the £1,000 prize put up by the Daily Mail to be the first person to fly across the Channel. Within 10 more years just, John Alcock and Arthur Brown had crossed the Atlantic, so across the Channel, across the Atlantic, and within 50 more years from that, we'd flown all the way to the moon. So after that first breakthrough, the world got huge amounts of attention. They said, my God, this does work. There's so much potential here, potential for military stuff, but potential for commercial, potential to understand the universe. My view is it will be the same with the Rejuvenation project. Just one more remark on the history before I move forward. One more date is worth picking out. Go back 120 years earlier, 1783. There was another landmark in flight, which something very interesting happened. That was when the Montgolfier brothers had their first hot air balloon, which took humans up into the sky. And there's some interesting reactions. There's a picture from the time there showing the crowds being astonished. But one 80-year-old noblewoman is recorded giving a particularly far-sighted comment. She was not happy to see this because it made her realize that nature could actually be cracked, that the limitations of nature were vulnerable to human engineering, and she said, oh yes, she said, now it's certain, one day they'll learn how to keep people alive forever, but I will already be dead. And she realized that in a sense that these were the two same projects. But of course, we've got to consider, is this a real fair comparison? There were lots of different approaches for human flight, which led eventually to being solved by clever engineering, in which there was an explosion of interest, so that in just 60 years later, they were flying to the moon. There are many different approaches to human rejuvenation, genetics, telomeres, regenerative medicine, and so on. In this room, most of us believe they will eventually be solved by clever engineering, and there'll be a fast progress after an initial demonstration. And I'll talk shortly about what that initial demonstration might be. But there's a big difference between these two projects in terms of effort. If this project here has effort n equals 1, how much is the effort to get this other grand engineering project? Is it 10 times as much? Is it 100 times as much? I think it's probably at least 1,000,000 times as hard to solve all the problems we've been hearing about in the last few days, and possibly even 1,000,000,000 times as hard. I don't think it's infinity times as hard. I don't think there's any argument that this cannot be done. After all, there's plenty of examples of rejuvenation in nature already. Creatures that can generate new limbs, even in the brain, new cells can be generated. It wasn't thought to be possible in the past, but we now know that it is possible. There is other rejuvenation mechanisms, such as the immortal jellyfish that can revert to a juvenile state. Some organisms, such as the naked mole rats that we heard about earlier, seem remarkably resistant to cancer, so their rejuvenation methods, whatever they are, seem to be working very well in at least some aspects. And then there's the remarkable fact that an old body, the old human body, can give birth to a young body by mechanisms of stem cells and so on. So there's lots of mechanisms there which in principle could be used in new ways to get this effect of a continuing rejuvenation. And of course there's been many interesting experiments shared here over the last couple of days which takes things further. Young blood may hold the key to reversing aging is one headline from a few months ago in the New York Times, in which the blood from young mice were transfused into older mice by some complicated mechanism, and the muscles and the brains of these older mice then started looking like younger organs again. There is the telomerase gene therapy, which extended mouth lifespan by 24%. Experiments by Maria Blasco's lab in Madrid, which I'll say more about shortly. There are plenty of experiments, and so I'm not saying that any of these by themselves will be the solution, but there are plenty of building blocks so that we can have the idea that clever engineers, given enough time, given enough effort, will be able to reverse aging in steps. But supposing it is 1,000,000 times as hard, will it take 1,000,000 times as long to solve all these issues? If it took flight engineers, say, I don't know, 10 years of very serious work after they started in the 1890s to the mid years of the first decade of the 20th century. If it took them 10 years, it's going to take us 1,000,000 years to solve this. And I would say no, because of the exponential growth of the field. As more and more people are drawn in, and I think it's very likely that every decade there will be at least 10 times as many researchers looking at this field as there was in the past. When I say researchers, I mean proper, bona fide academic researchers. I also mean citizen scientists. I mean people who are able to do some reading up and do some experiments by themselves. People who retire, people who are unemployed, who still contribute. And then there are people in huge industries. There is the pharmaceutical industry, there is the IT industry. After all, a lot of the issues in rejuvenation health are IT, big data, analytics. There are many people in the food industry, the sports industry, and the cosmetics industry. So every decade, I believe it is quite likely there will be at least 10 times as many people. And if we go out 60 years, if we start out in the 1980s, the first serious work done on longevity with the work of Michael Klaas, figuring out, and his colleagues who eventually figured out that certain genetic changes could significantly extend the life of the C. elegans. So 60 years later, there will be probably 1,000,000 times as much work being done on the field, and that is why I think that it's quite credible that by about 2040, these problems will be solved. But critics will say, hang on, you can't just put 1,000,000 people in a room and expect them to get things working very well. There will be huge amounts of coordination problems. And in the world of software, which I come from, there is a law called Brooks's Law, named after Frederick Brooks, who wrote a book called The Mythical Man Month, who pointed out if you give 9 women a job to give birth to a baby, you don't get it done any quicker than 9 months. His law states that if you've got a software project that's running late, and you put more engineers into it to try and speed it up, you'll actually make the project even later. Why? Because there are coordination issues, there are communication issues, and there are training issues with bringing new people on board. And there's also the worry that if you get many more people working in this field, we'll just generate a lot more low quality stuff. There'll be some valuable stuff that's generated by a few great researchers, inspired people, but there'll be a huge amount of noise. Well, I say, yes, these are real problems, but I say industry is figuring out ways how to solve them. Industry has got the methods, smart coordination tools and processes, which will allow us to coordinate more effectively. And concretely, there are things like education, which can bring people up to speed all over the world, whether they're in Bangalore, whether they're in China, whether they're in the Philippines, whether they're in the Middle East, whether they're in South America. People will be brought up to date much more quickly. There are components and tools which have been developed which other people can quickly take advantage of. There is a culture of wikis in which the best information comes to the top. Open source so that people can see each other's approach, and very importantly, platforms. The way that so many people in my own commercial background industry, the mobile phones and smartphones were able to coordinate was because of very powerful platforms that emerged, whether it was iOS or Android. And so because of the emergence of platforms which figure things out, such as the Sense platform or other platforms, more and more people will be able to coordinate. And the other thing that's going to help this coordination go is increasingly useful artificial intelligence and software, data analytics, and so forth. Critics will still say, well, let's get real. Let's look at a very real curve, a depressing curve known as Eroom's law, which points out that actually, even though there are lots of people active in the field, the amount of effort, the amount of money that needs to be spent to get a new drug approved, that has gone down logarithmically. So this is the reverse of Moore's law of accelerating exponentials, hence the word Eroom, which is more backwards. It's not a name, it's a clever name that explains that there is a decline. So once upon a time, it was somewhere between 10 and $100 billion R&D spend would get a new drug all the way through and into use, whereas now the number of drugs per $1 billion. Once upon a time, $1 billion in US spend would get somewhere between 10 and 100, but it's been coming down relatively steadily, and now it's shockingly poor because of the amount of time that's taken to go through tests and the amount of time it's taken to pass regulation. And people say, well, this will not be solved just by having more people, and I agree. But I have 6 answers to Eroom's law. I think, first of all, the fact that this is now being discussed is a big step forwards. It was only published and became highlighted just over 2 years ago, and the industry is now much more aware that this is an issue, and awareness of an issue is the first step to actually solving it. Secondly, the industry is open to consider changes in the way the regulatory and testing frameworks work, so that they're able to realise, no, we don't need to go through these things sequentially the same as before. Some things we can do in parallel, and indeed things when there's a crisis such as the Ebola epidemic threat, that people are able to take shortcuts and get drugs out there more quickly. I'm not saying every drug should be shortcut in exactly the same way, but there are mechanisms that are in place. Third, there are lots of potential new technologies, but more than just new technologies, there are new working methods and new business models and new players which can actually accelerate things. The new technologies are things like nanosurgery, synthetic biology, 3D printing and so forth. The new business models, well, let's take an example from my own background. The mobile phone industry, the smartphone industry got quite far with a certain set of major manufacturers. Companies such as BlackBerry and Nokia did very well for a while, and then they got bogged down and things slowed down and they did not make much progress, and they took them longer and longer to get new devices out. But what did happen is that new players came in, people who were not expected to be champions in the mobile phone industry, companies such as Apple, companies such as Google. They brought new technology, but they also brought new ways of working, they had new relationships with the network operators, and they transformed that industry. I think it'll be the same with the rejuvenation industry. To an extent it will be driven by people inside the industry, but to an extent it will be driven by new players. Again, it might be Apple and Google as it happens, and both of them are very interested in healthcare, and they have the power and the confidence to find new regulatory approaches. And then there are the opportunities for advanced computer models such as IBM Watson, which is already doing fantastic work in understanding large amounts of medical literature faster than any humans can do. And then there are the fact there will be more people involved, and out of these more people there will be some people who realise the better ways to work. And last but not least, and here I come to the philosophy of science part, last but not least, there will be different ways of looking at things, especially if people realise a sense of crisis and a sense of opportunity. It will galvanise people to be much more serious, much more urgent, much more focused in solving these problems. So let's talk about this possibility for people to change their perspective on this, not just to go along saying, well, it's a bit inconvenient, it's a bit of a drag, but we'll cope with it. Let's see what can be done. And here I'm going to look at the notion of a paradigm shift. I'm going to take this idea from philosophy of science. This is a very famous picture which has been written about by various philosophers, including Thomas Kuhn in his 1962 book, The Structure of Scientific Revolutions. What do you see here? From one perspective, you can see a duck, and from another perspective, you can see a rabbit, if you look at it from the other way. And both valid, both make sense. It's hard to see them both at once. And he says a lot of scientific change is a bit like that. People get stuck into seeing things one way, and it colours all how they understand the industry. And what we're going to see in the next few years, I believe, is a paradigm shift as how we look at the problems of death and disease and aging. So this is an easy example. Let's look at a harder example when there are two different perspectives and it's very hard to combine them both at the same time. This guy on the left sees 4 and the guy on the right sees 3. If you look at this diagram too long, you'll go mad, so don't look at it too long because it's a geometric impossibility, but it shows that sometimes the discussion breaks down because people are locked into one perspective. They don't even realise what's colouring the thinking, the filters that are in their minds. From one point of view, this guy on one side, the guy who's saying, no, there's only 30, he's aware that the other guy has a different perspective, and it's kind of a strange thing for him. It's a sort of an inconvenience. He doesn't worry about it so much. But from the other guy says, no, this is a profound issue. We have to address it. This is a crisis for the theory. So let's look at that in a couple of examples. After Thomas Kuhn's book came out, there was a scientific revolution in the field of plate tectonics that took place in the next few years. And here there were two different perspectives on what you look at, how the continents might fit together. You know, every child looks at the map and says, you know, that bit of South America might fit into Africa. And everybody said, don't be ridiculous, you know, the oceans can't move. That was the view that was common for 100 years. It was just kind of a coincidence, a kind of a weird, childish notion that the continents might move. And people found lots of interesting data. They said, well, if you look at the fossils and the flora and the fauna at the edges of the continents, if you look at the top, they're different. But if you go down a sufficient number of millions of years, the stuff that's on the edge, the fossils that are on the edge of Latin America are quite similar to the fossils that are on the edge of Africa. It's another piece of evidence that there could be a solution here in which they all were initially together. And again, the big guns in the world of geology all said nonsense, and this hypothesis was largely ignored, scorned and ridiculed, pushed to the outside of science for a long time, until more evidence was accumulated. People actually looked in the oceans, and what did they see in the oceans? They saw that there was new mechanisms. They saw that there were ocean trenches. They saw that there was lava there. They saw that the lava had been solidified into magnetic stripes, which made sense that the oceans actually could be moved aside. There were submarine volcanoes. And as this evidence accumulated, in just a few years, all the old guns of the industry said, you know, we were wrong. It is true, these continents can move. I predict it'll be the same with the attitudes towards human deterioration, aging and death. A lot of the industry, a lot of the established academia sort of says, you know, this is an inconvenience that this happens, it's at the edge of life. We've just got to learn to accommodate it. We've got to, in the words of the famous prayer by Reinhold Niebuhr, the German pastor, we've just got to have the serenity to accept what cannot be changed, and we make a virtue out of this thing that's happened. That's one perspective. The other perspective, which many of us in this room have, says, no, this is a crisis. It is a crisis for individuals who die, it's a crisis for families who lose loved ones, it's a crisis for society because of the loss of wisdom, because of the loss of potential. These people who die, even if they are 75 and they've had a long, full life, they've got lots more that they could do. It's a crisis for demography because of more and more elderly people with a small number of younger people looking after them. And it's also an opportunity for a huge new industry, the rejuvenation biotech industry. So this side of the paradigm shift sees things differently. They point out the second clause in this prayer. Oh God, give us the serenity to accept what cannot be changed and the courage to change what can be changed, and the wisdom to know the one from the other. And so there's one side who says, let's be serene, let's not get our hopes up too high, and the other side says, we have the wisdom to see that things can change now in the next 40, 50 years in a way that couldn't happen before. So let's go back and then look at our critic, Dr. Emmanuel. What actually did he say in his article? He said that death is preferable to enfeeblement. He said it's terrible when people get disabled. It's terrible when people falter and decline. It's much better if our children, our grandchildren remember us as vibrant and engaged instead of somebody who's drooling and feeble and ineffective and pathetic. Let's not get old and lose our creativity. Let's just die quickly when we are 75 or thereabout. And he said, look, medicine has failed. Medicine has tried to extend life, but in fact it hasn't managed to extend life. It's actually slowed the dying process. He points out in his article that in 1998, people who were over 80, only 28% of them had some functional limitation, whether physical or mental. But now that figure is much higher. There is a crisis of old age care. And his solution to that crisis is to say, let's realize the best work of our life is done when we're young. Let's not try and drag it out. Let's do what's necessary to just die peacefully and calmly after we're 75. His evidence that the best work is done early in life, he has this chart looking at the productivity of creative people, and he says the people who get Nobel Prizes, for example in physics, most of them, the average age at which they do that work is 48. So, what's the point being around when you're a bit older? Let's move away and let the 48-year-olds get all the lion's share of the resources, instead of these older people taking too much. But there are lots of contradictions in his article. At least we see them as contradictions from a perspective that there is something that can be done fundamentally about aging. He actually quotes Albert Einstein in his article, and most quotes from Albert Einstein seem to be wrong, made up, but this is a real quote that Einstein did say. Einstein, who did his great work when he was aged 26 in his Annus Mirabilis in 1905, he said that a person who has not made his great contribution to science before the age of 30 will never do so. And Emmanuel in his article said, well, things have changed, people do get better at doing things later, hence 48. And he has another example in here. He said that, well, there are some people who do great work when they're older. He did some work with somebody who was about to turn 80. It was an incredibly productive collaboration. He was brilliant. He continues to be a major contributor even when he's 90. So what does that do for the argument that 75 years is enough? Well, his argument is, this is an exception. They're just an exception. Don't imagine you can be an exception. Don't imagine that things can be changed. In other words, he is still stuck in his paradigm. He still sees things from one perspective which says, deterioration is inevitable. Let's not fool around with it. Let's just accept it and let's do the best we can in this situation. And it is interesting that it's hard for people to change paradigms. It is interesting that even if you're very clever, there's lots of evidence that intelligent people don't change their minds more easily. What intelligent people, like Dr. Emmanuel and many other critics do, is this. In all fields of discussion, this is not just about longevity, this is about whether you should change from one grand way of thinking about the world, one paradigm to another, whether it's a discussion about climate change, whether it's a discussion about do you deny evolution, whether it's a discussion about gun control, or whether it's a discussion about whether the free market should operate or not. Intelligent people don't look at all the evidence fairly. They search out justifications for their beliefs and loopholes in their criticisms. There's something called the smart idiot effect. The smarter you are, the more easily you can be motivated in an unconscious way by reasoning that preserves your opinions. So if you're locked already into a viewpoint that says that death is a sort of inevitability, you will find plenty of things to bolster your views. People stick to positions that they have invested lots of personal and social effort. They're worried about, well, I'm the kind of person who's a certain viewpoint. People like me take these views. And so I'm a member of they will think I'm a member of a respectable establishment. Our establishment has survived by people dying and moving away, leaving space for people coming behind me. That is the kind of arguments that are going on at the back of their mind, which lead them not to reason, but to rationalize. A very interesting video on this, The Science of Why We Don't Believe in Science by Chris Mooney, which is worth looking up, as he has looked particularly at the issue of why people are locked in so hard in views such as climate change or gun control and don't change their minds. But it's certainly applicable as to why people don't change their minds easily on aging. And indeed, people are sometimes terrified of the consequences of accepting a different idea. Not only does it mean, well, I won't fit in with my social gang anymore, people like me have this view, there is something deeper at work in the whole field of views about aging. Don't have time to go into this deeply, but it's written up a very interesting way, the theory of terror management theory by Thomas Brzezinski, professor at the University of Colorado Springs. He talks about the fact that everybody goes through a crisis at some stage in their life, often when they're young, when they're terrified about the idea of aging and death, and we all, at some quite early age, get some mechanisms to help us cope, and this mechanism is a whole set of beliefs, it's a set of culture, and this culture prevents us being terrified, and we hang on to that because we know at a deep level if this gets disturbed, then bad things might happen to us. That's the view. And he points out there is a paradox that people actually oppose the idea that we can have longer and healthier lives because of this set of culture, because of these philosophical ideas, which at one stage made sense, but no longer do make sense because of the new technological possibility. So my last historical example is changing mindsets. How do actually people change from being stuck in one set of views, driven by terror and so on? How do they change? I'm going to pick an example from 1978. This is the time when the people were imagining that it might be possible to grow babies in test tubes. And there is a comment that was made by this group here, man shall not seek to create life by artificial means. There was a quote, it is an abomination in the eyes of God for man in his arrogance and pride to seek to create the living human being. What he is creating in the test tube won't be a proper human being, it will be a soulless monster. I don't know who said this. It was apparently Our Lady, the Virgin, who had the benefit of a human interlocutor who managed to communicate this fact. It wasn't just religious people actually who were opposed to test tube babies, vigorously in many cases in 1978. Many of the politicians thought it was a bad idea. And the politicians disliked it because, first of all, they wanted to get the support of the religious vote. They wanted not to stand out. But also, politicians were concerned about other lobbies. They were concerned about overpopulation. People were worried at the time, you know, we're bringing too many people into the world already. Now what? You're going to bring more people into the world by test tube babies? You guys, what are you thinking about? How much is that playing God? What a bad thing. And most scientists were actually opposed to this as well. Most scientists said, this is not going to work. This is a terrible idea. It's just going to lead people to pain and misery. And the people who did this work, Robert Edwards and Patrick Steptoe, they couldn't get funding from any of the proper resources. The UK's Medical Research Council turned them down. They only managed to do the work because they had some private benefactors. And they had a miserable time. So Robert Edwards, he already conceived the idea in 1950 that there could be test tube babies. He worked on that for a long time. From 1970, he figured out how to get the eggs out by without such drastic surgery. From 1970 to 1976, they tried 1,000 times to have a baby implanted, and there were 1,000 out of 1,000 cases of miscarriage and pain and anguish. And no wonder that the fellow doctors and scientists were saying to Edwards and Steptoe, give it up, you guys have got huge egos, what are you doing? And then what changed everything? Well, there was an engineering change. Edwards and Steptoe figured out changes in how to regulate the hormones so that the woman wouldn't miscarry. And then this super baby, Louise, the world's first test tube arrival, and she was a charming baby. And people got to say, what nonsense that these creatures are soulless. They've got the vitality and the beauty, and soon there were lots. And soon all this nonsense about man should not play God, and soon all this nonsense about it's going to contribute in unprincipled ways to the population explosion change. Super Babe reminds me of the super flight in 1908, when the Wright brothers were flying above the aristocracy in France, and people could see very clearly this is not just some smoke and mirrors, this is real. And I foresee in the not too distant future, not Super Babe, not Super Flight, but Super Mouse. Super Mouse will come, perhaps, and I've even put the date here 2012 for a reason I'll explain, but sometime in 10 years after that, there will be mice which have had enough benefit of rejuvenation technology that people suddenly say, hang on, I've got it now. I'm no longer looking at this as a duck, I can see it as a rabbit. I've got into this different mindset, and all kinds of things will change. The 2012 experiment I already mentioned. It was done by the lab in Rio Glasgow. Some commentators latched onto it, not many, latched onto it. A giant step for mankind that started with a mouse. The Big Bang study of the year is Dr. Glasgow's latest study. It is gigantic for several reasons. Normal mice with a single injection that set a viral transpose at work. 1-year-old mice then, as a result of this injection of telomerase genes, had their life extended by 24%, and the mice who were a bit older, 2 years old, already had a 13% increase. And very critically, no cancer, because everybody had been worried. This was done actually in a cancer lab team, and it didn't get as much coverage as you might expect, and we can look at the reasons for that. In some ways, the growth in aging is not that dramatic, but once the experiments are done that extend the age of mice by 100% in mid-age, I think lots and lots and lots will change. So, it's more than I could say. Would love to cover more, but let's skip to the end. I'm trying to cover some of this in the new book, Approaching Rejuvenation, is Science at the Point of Radically Extending Human Longevity. I don't know, it might take me 1 million years to write, and I'm hoping I can get it done by 2015. I'm hoping I can accelerate my progress. I'm very keen to talk to the people who are in this field about your own experiences. There's lots of books already, of course, on this, but I think we have to communicate, communicate, and communicate. We have to find different ways to get people to see things from this different perspective. We have to show them the credibility, we have to show them the plausibility, and we have to show them the desirability. So that is some of what we can learn from the critics of human rejuvenation. If any of you would like me at some stage to go into the longer version of this, and I'll look at more of what the critics say, I'll be very happy to do so. So thank you very much.
So we're running a little bit late, so maybe use the coffee break to ask your questions personally to David, and we meet back in 20 minutes inside. And in the meantime, we figure out how to work this new magical machine.
Maybe.
Wait, we got a special intervention.
Maybe I would like to do one question. I would like actually to ask the audience as a whole. Could the audience say their opinion of why they believe Eroom's law is happening? What the possible reasons are? And if you know some solutions, of course, that's great. Speak up.
Well, I think people do know why Eroom's law is happening. It's been quite carefully explained in the original article. And maybe Peter has more to say.
It's more of a question, but does that take account of inflation, this graph?
I think it is inflation adjusted. It's not just a matter of inflation that explains it.
Maybe that's a bad saying, but I was told a few times, I don't know if that's true, that the pharmaceutical companies wanted to, at the time when they were quite big, they were lobbying for even stronger regulations in order to preserve their position in the market. And so in the end, things changed for them, and now it's difficult for them to make money. So they are trying to go back to this position.
Yeah, so a lot of these regulations, they're there for reasonable reasons. They're not there for foolish reasons. It made sense at the time. It was the same in the mobile phone industry. There were lots of rules that were introduced. They all made good reasons, and then somehow it slowed down progress in the existing major companies at the time. But it did open the way for new, nimbler, smaller, and more dynamic companies to break in. I think that some of the pharmaceutical companies will find ways to shortcut the process, and they'll find ways in which it makes good sense to do it without significantly sacrificing safety in the process. So there will be dynamic changes in the industry. And I think we can help them to get there by pointing things out. Edward, one more point?
Oh, and one point I would like to make. Could there be a change in the types of diseases that people go after of the time, and that they have just progressively going to more difficult diseases or more difficult types of therapeutics, which might be, like antibiotics in the beginning, that's quite easy to screen for. You just in labs grow bacteria, you test all types of different fungi and other bacteria for chemicals that they produce. Can they kill them? It's easy to do. An undergrad can do that type of work. But screening for a drug against heart disease is already much more complex. Could it be that there is this evolution?
So I don't think we should underestimate the problems here, and that there's not a simple fix. If there was a simple fix, it would be done already. But we can engineer it, and it will require a process engineering on a par with the pharmaceutical engineering as well. I do spend about 5 pages in my last book, in the last chapter of my last book, Smartphones and Beyond. I do analyse Eroom's law, looking at what the industry has said about it, and give my confidence for why it'll be hard work, but we can solve it, and we won't be bogged down, and we will be able to accelerate these changes.
Yes, sorry. So this is something I don't know well, but within the International Longevity Alliance, there are specific teams for that. So many people are trying to find ways to get people to test new treatments, in particular, for example, cancer patients, and they are working on trying to convince local governments. For example, one state in the US, well, it's about marijuana, I think, but they are trying to say that perhaps if the patient is sufficiently well informed by making a specific test, like a scholar test, approved by some ethical committee, then we can give them the treatment, because they know the risks that they are taking, And that could be, also they would engage in building a sort of database of knowledge. And so quite a lot of people are trying to define that with some lawyers and some ethical committees for it to spread over the world. For now, it's just one state in the US, but the goal would be to spread that because that could be one way to faster develop new therapies in humans.
In the UK, there's something called CASME, I think, run by Richard Colin Barker, Richard Barker, which is doing exactly this. So it's happening in the US, it's happening here, looking for alternative processes that could be applicable. So we will figure out a solution by one means or another, and it's good that we have separate teams working on it so they can learn a bit from each other, but they can also pursue their own independent ideas to solve this problem and get more people engaged and accelerate the process.